Filament winding is a technique primarily used to manufacture hollow, circular, or prismatic parts such as pipes and tanks. It is performed by winding continuous fiber tows onto a rotating mandrel using a specialized winding machine. Filament winding results in a high degree of fiber loading, which provides high tensile strength in the manufacture of hollow, generally cylindrical products such as chemical and fuel storage tanks, pipes, stacks, and pressure vessels. This lecture dwells upon the basic concept and processes involved in manufacturing of fiber-reinforced composites products. First commercial winding machines were developed in early 1960s. Their operations were manual and mainly used for tubes. Special machines were developed for pressure vessels, including tumble, winder and polar, spherical, winders. First computer-controlled winding machines were introduced in late 1970s, which made winding process relatively easy. However, these were considered to be not very reliable and difficult to program. Programming methods were a mixture of calculation, trial and error, and teach-in. In early 1980s, CNC-based winding machines hit the market. This resulted in fast development of high-end and specialized products. Control technology was developing rapidly from companies like Bosch, Fanuc, NUM and Siemens. Filament winding is a mature technology. Machines are now becoming standardized and have lower cost. They are now being used in companies of all sizes and are no longer dedicated to defense, aerospace and corporate R&D centers. Machines with different winding axes are listed on the screen along with potential use by manufacturing industries. Price tag exponentially increase with greater number of axes, 5 or more. The simplest winding machines have 2 axes of motion, the mandrel rotation and the carriage travel, usually horizontal. A 4-axis machine additionally has a radial, cross-feed, axis perpendicular to carriage travel, and a rotating fiber payout head mounted to the cross-feed axis. The payout head rotation can be used to stop the fiber band twisting, and thus varying in width during winding. Machines with more than 4 axes are used for advanced applications. Specialized softwares are used in modeling the winding process. One such software is CAD-Fill. It creates high-performance composites in minimum time using CAD-Fill. Complete FE analyses are carried as essential component. 6 axes are described as 6-axis articulated arm, similar to humans. 6 axes allow a robot to move in the X, Y, and Z planes, as well as position itself using roll, pitch, and yaw movements. A big advantage of filament winding is that it uses continuous fibers, which leads to very good material properties for both strength and stiffness. There is also the ability to orientate fiber direction for optimized composites. All types of fibers can be used on winding machines. Similarly, wide variety of resins, as shown on screen, are easily utilized for this technique. In filament winding, final fiber content is a function of the radial motion of the fiber with respect to the resin during winding. Filament winding technique is unable to wind on negatively curved, concave, surfaces. Some of the products produced through filament winding and listed on the screen include sports gear, automobile and boat parts, pressure vessels like oxygen cylinders for firefighters, and mountaineers are easy to carry due to lower weight of cylinders. The concept of axes used in filament winding machines follows this lecture. A short narration having identification symbol as CMB54.